2D relative motion. Now we're talking not planes, trains, or automobiles, but a boat or slash canoe, something crossing a river. This is another very typical old school physics problem. So what you've got here is imagine the two black lines represent my river. Okay. If you're going directly across the river, you are headed due north. The river has its own velocity of 3.2 meters per second east, so the water is traveling sort of this way. And we're saying that in part A, the canoeist, who, if it was still water, could go 4.5 meters per second, is aiming, so I'm pointing, this red vector represents where the canoeist aims directly across the shore. That's where they're aiming. However, because of this water current, obviously, obviously the canoe is going to get pulled downstream. And so the question is, what will the resulting velocity be relative to the shore? And that's just this vector right here. So if you look at it, it is just a Pythagorean theorem question. There's nothing really else to do with that. So in part A, just a quick thing, I guess, on my variable names. VRS is river speed, canoe speed, and still water, and that's the resulting speed relative to shore. So being a right-angled triangle, just solve that triangle, use Pythagorean theorem. You get a magnitude of 5.5, and 35 degrees is the angle in the middle. So the resulting velocity of the canoe relative to shore is 5.5 meters per second, 35 degrees, and I'm saying east of north because straight up is due north in this case. Okay, so that's a fairly straightforward one. Just pause the tape if you need to keep writing, so I'm going to move on. Part B is saying, well, how long will it take to cross the lake? And this is an interesting question. Lake, river, I guess. What you need to say to yourself when you find the how long, of course, is time, is what is the speed of my canoe? Like, I know the distance straight across is 220. Well, what is the speed in that same direction? And the speed in that direction is the 4.5 meters per second. I think there's a tendency for students to want to use this velocity, the canoe with respect to shore, and that would be fine if you're using this distance, this distance that's on an angle. But since we're looking for we have a distance straight across, as long as we use the velocity straight across, you'll get the correct time. So this is just a uniform motion question. Okay, so the time to cross the river is the width of the river divided by the velocity in the direction directly across. So solving for time, it takes 48.950 seconds to cross the river, which I think is a reasonable number. Okay. Again, if you need to write, just pause. Part C is asking us how far downstream the canoeist will end up. So just excuse me, I'm going to look at the original question. So it's saying, where's its landing position relative to its starting point? So, well, that's interesting. So I solved that question. I read it to be how far downstream, which you could also, looking at the language, you could read that to be, what is this distance right here? And if you're wondering how you would find that, you would just take the 5.5 meters per second, that's the speed in that direction, and multiply it by the time to cross. And that would give you the distance, and then you could use the angle. Because I read it as downstream, which usually the question is downstream, I used this speed to find out how far in the sort of east direction the river current takes the canoeist. Okay, and so just coming down to here, to find out how far downstream the canoeist will end up, we use the velocity of the water and the time it's in the water for. So 156 meters, 156.5 meters it ends up. So that's a pretty good answer, makes sense. In 50 seconds at 3 meters per second. Okay, part D is where the question becomes a whole new problem. It's all you can see underneath. I redrew it. So part D says, at what angle should the canoeist aim in order to land directly across? So this time, they're not going to aim straight across. They're going to aim up here somewhere, right? They're going to aim off in this direction so the water current carries them to land directly across. So this is the picture. Okay? Now what changes is, this is where they're aiming. So where they're aiming is always, where the canoeist aims will be the velocity with respect to water. That's the 4.5. We don't know now the velocity with respect to shore, but it's actually not that important because we're just looking for this angle, right? So we know this is 4.5. We know that 3.2 is still the same. And so we're just looking for the angle. So you can use, in this case, sine, because this is opposite. And this is the hypotenuse, right? Yeah, so sine. So in other words, he's got to aim or she's got to aim 45 degrees, and in this case it'd be west of north. Okay, so that's a very typical question. Again, if you need a little more time with it, you can review, watch it again, or you'll see something in your assignment. You can practice it at that time.